Good afternoon, everyone. Are we ready to learn something about data mesh? Some experts of data mesh in the room? Okay, then
That's good.
we will pretend to be the experts today then. First, we have the QR code here for the session feedback. It will also be repeated at the last slide. We would appreciate feedback, both good and bad. If you think we suck, that's totally fair. But we would like to know why you think we suck. But another thing is that if everybody fills out this form, and then at the last question you can select which charity you would like SQLBits to support. So by entering the session feedback forms, you also support a charity. So if not only to do that. Okay? We will start by taking you a brief trip down memory lane. So that was when I started working. That was actually, if you believe it or not, that was last century.
Last millennium.
Millennium.
Yes, you're that old.
Okay, anyways, talk a little bit about the history of the architecture of data analytics systems. So back then, we didn't have that many operational systems. And when someone needed to get some insight, some information from the operational system, what we did that we used some kind of reporting tool. Crystal reports was the shit back then. And we built our reports and everybody was happy.
Yeah. I see at least some who are not as wide as me, but have you developed in Crystal reports? Yeah, see.
So what happens then is what usually happens when we have two different kinds of users kind of badgering the database. So the report users get more, we get more of them, and we get higher volume in the operational database, and we get this classic conflict. So, and also the report users, they admit we really don't need real-time data on our reports. So okay, they accept we can set this up that we take a backup each and every night, and then we restore this database beside the operational database, and we call it reporting. But this is only one system. And the organization have several systems they would like to maybe correlate data across them. So then the next generation, or the first generation of a data warehouse, the need for that is kind of born. And we have several data sources, and for each data source we have one or more jobs that extracts and maybe do some transformation of the data, and we load them into the data warehouse. And we have even more data sources, even more jobs, and more data sources, even more jobs. And you might have experienced this yourself, is that you are maybe just a small team to handle this, to handle the expectation to connect to new data sources, or to build new jobs, or to maintain existing jobs, existing reports. And you're running the risk of, well, creating this mountain of technical debts.
It's what we call you deliver what the user asked for after they've forgotten what they asked for. It's a perfect solution.
Exactly. So, okay, how do you solve this? How do you kind of get away from all these jobs that you need to maintain? Well, then the big solution is then, that solves all problems, at least that's what we believed at the time, is, yeah, we move everything into the big data system, or the data lakes. Then you don't have to maintain those jobs any longer, right? Because then you do that when you extract the data, maybe in real time-ish.
Well, it didn't have to be real time, but the thing is, we could just dump everything in, and the users couldn't complain that we were late. Perfect.
Yeah. Exactly. So you have this fantastic big data system, and where you can put all your data in, maybe data you hadn't really thought about that you could store in an analytic data warehouse or a big data system. But then you also are running the risk that if you haven't done this, following all the best practices, you don't really any longer have a data lake. You have more something looking like a data swamp. And what you're also running the risk that you also have this big data monster. That's what you have built. So big data for many has kind of been overpromised and also underrealized. So how do you solve this? Well, then we have the third generation of systems. That's the current generation of systems, where you also have the ability to add streaming data. So we have the opportunity now to do real-time analytics and to solve the problems or challenges with handling larger volumes of data and the lack of compute resources. Okay, then we put everything into the cloud. Then everything is solved, right? The thing is, if you're following the same bad practices, you're still running the risk of creating a data swamp. Now the data swamp is in the cloud, but it's still a swamp, and we have the occasional data monster lurking behind, right?
Now it's the cloud data monster.
Cloud data monster, that's what we have now. So this lady here, Shamak Degani, she recognized this is a problem. And she thought of a way to solve this. And she wrote an article back in 2019, which was titled How to Move Beyond the Monolithic Data Lake to a Distributed Data Mesh. And she followed up that article a year later, going more into details about the principles. And she also, after that, what one does is write a book, which goes into even more depth.
And now she's gotten even beyond that, which is the natural next step, which is make her own company that delivers data mesh.
Exactly. Yeah. So her mindset and her aim is going to solve this problem of this monolithic architecture, which all have common failure modes and also have these unfulfilled promises at scale. And doing that by shifting to a paradigm that draws from modern distributed architecture, inspired by the software design approach called domain-driven design. So what kind of problems does data mesh aim to solve? And there was an article written by a guy called James Serra. He's a consultant at Microsoft, and he wrote a blog post called Data Mesh Defined. And in this blog post, he summed this up in a really good way, I think. So first of all, it solves the problem, or it aims to solve the problem of the lack of data ownership. So who owns the data? Is it the team that owns the operational system, the sources? Or is it the infrastructure team that extracts the data and puts them in some kind of data lake?
If you ask the DBAs who own the operational systems, it's theirs. How many have tried to argue to get access to that data set? It can be quite a challenge, yeah?
Exactly. It aims to solve the problem of data quality. So the infrastructure team is now responsible for the data in the analytical system, but they don't necessarily know the data that well. And the third thing is the problem of organizational scaling. So since traditionally, and still is, the team that's handling the analytical systems, they are often very few people. And they become this, this bottleneck, right? So this is what data mesh tries or aims to solve. So data mesh consists of 4 principles. The first principle is domain-oriented, what does it say? Decentralized data ownership and architecture. That's quite a mouthful. Luckily, she renamed this to the domain-oriented ownership, so let's use that going forward. So what is domain-oriented ownership? So from this existing model, where one extracts data from the different business domains into a common data lake, We're shifting from that to decentralizing the ownership of the analytical data to each and every business domains closest to the data, either the source of the data or its main consumers. And it's natural to split this up in a way, or decomposing this in a way that aligns with the existing business domains in an organization. So why? Well, they are the ones that knows the data, right? They have the domain data knowledge. It's also natural that they should also then be responsible for the quality of the data. So we get this shift from push and ingest to serve and pull. So each and every domain serves the data so others can pull them. And it doesn't necessarily only have to be, business domain, because one could set up shared domains where all the other business domains can extract data from and correlate across the organization. So an example of a shared domain could be a customer domain. The second principle is data as a product. So what is data as a product? So let's say we have this business domain with which has several data products created, and each and every data product has a set of APIs. And data as a product adheres to a set of usability characters. First of all, it needs to be discoverable. We need to know where can we find data products, and a way to implement that is through a standard data catalog. It needs to be addressable. So where can we find this data product? What kind of hyperlinks should we use? What kind of addresses should we use to get this data? It needs to be understandable, obviously. So for each and every data product, that should have a set of documentation that thoroughly explains what is this data product, what are the different attributes in a data product, and what can we use it for. It needs to be trustworthy. It needs to adhere to a set of best practices of data quality. We need to know that actually this is the truth for this type of data. And maybe also following that, it could be have applied some kind of policy of service level objective that one has agreed upon across the organization. It needs to be natively accessible. By that I mean that there is different kinds of users that would like to use the data products. Let's say the data analysts, they might want to use SQL, do querying across the data. So that kind of interface needs to be there. Maybe they would like to get the data in form of CSV file format. And let's say there is a data scientist. Yeah, they want to do machine learning training, and maybe they want the data in a form of data frames. Or they could be an application developer who, I want to have access to these data through a REST API, right? So each and every group of users should have accessible, their form of the type of APIs that they are used to use on a daily basis, right? It needs to be interoperable. So that means that data across domains should mean the same thing. So a vendor in one domain should be the same as a vendor in another domain. And it needs to be valuable on its own. So a data product should have meaning in itself. If it needs to be correlated with some other data product in order to get some meaningful insight, then maybe that is not a good candidate for a data product.
Just cutting in while you're taking a break. The slides are available for download afterwards. You don't need to take pictures, so if you don't want to, you will get all the slides.
But of course, if you want to share it with a colleague right now, please take pictures.
And we look especially good up here, so yes, you can take pictures as well.
It needs to be secure. By that, this kind of makes sense by itself. Only those who are supposed to access the data should get access to the data. The data should maybe be encrypted in a way, maybe in transit, at rest. Maybe there are some retention policies applied to the data so that it has some kind of limited validity. That is also a part of the being secure. So the third principle, self-serve data infrastructure as a platform. So this is a domain agnostic platform shared across the domains in the organization. And it has the, all the functionality that you need in order to handle and manage data products. It needs to have encryption, it needs to handle schemas, pipeline orchestration, big data storage, governance, and monitoring and logging. The platform needs to have all these characteristics. And the success criteria for this platform is that it lowers the lead time to create new data products. The fourth and final principle, federated computational governance. So what is that? Well, it's a shared responsibility between the domains and the central IT organization. And the focus is on interoperability across the organization, and also automatically deployment of policies. So the automatic deployment is the computational part of this principle. As an example, here's a group of policies that could be owned by a domain. So you have, they could be responsible for setting policies for data quality, for data classification, for data security, and that would be in the context of authorization, so who should get access to what data products. And more groups of policies here. And on the organizational level, the policies administered and owned by the central IT could then be data security when it goes to authentication. So are you who you actually say you are? And interdomain entity standardizations and global risk and compliance standardization. So these are just examples of groups of policies that could be divided across either on the federated level, across all domains, or within each domain. So what we then get is this kind of relationship between the different principles, this data mesh interplay. So on the domain-oriented ownership's relationship to data as a product, by data as a product, you then prevent data siloing. And also the relationship to the self-serve data platform, it empowers each and every domain to create new data products. And it also reduces the cost of ownership of data products, the platform itself. And the relationship between the domain ownership and the governance is that it increases engagement, also reduces domain isolation. And then you have the relationship with data products and the governance is that it gets the higher order value by interconnecting data products. And finally, the relationship between the governance and the platform is that you get this mesh level consistency of the platform and a reliable enforcement of the policies. So we can get this paradigm shift with data mesh. So we're moving from a centralized ownership on the organizational level to a domain-oriented, a decentralized domain-oriented ownership. On the architectural level, we are moving from a monolithic system to a distributed architecture. On the technical level, instead of data being a byproduct from code, data and code is one unit. And on an operational level, we move from top-down governance to federated computational governance. On the principal level, we move from data being an asset to collect to data as a product that we can share and connect. And on the infrastructural level, we move from a fragmented platform to an integrated platform. So my name is Rune, and my position here today, at least now, is that data mesh is the best thing reinvented since sliced bread.
So with Rune's hot air balloon here, my name is Johan and Rune. When I was doing army service, I was in anti-aircraft artillery. And my position is, So what if data mesh and what Shamak Segani was doing is beating down open doors? Yeah? Let's just take a look at this. This is the principles of a business data lake defined by Capgemini 2013. It's a long list. I'm not going through all of them. What is interesting are these three. So we encourage line of business to create point solutions. Domains, creating problems or building data in their domain for users. Let the line of business decide on the cost performance of the problem, distribution of products, and concentrate governance on critical points only. It corresponds quite well with this distributed common data platform, doesn't it? Then we have Databricks coming out with their data lakehouse in 2019, so around about the same time that Shigane came with her blog post. And some of the core principles of the lakehouse is the schema enforcement and governance, making sure that you go from a data lake approach where you have schema on read to a government schema and enforcement. You have storage decoupled from compute, again, so that people can access that independently. And it has the domain-oriented approach. So making sure that you try to focus more around the domains of the users themselves. So it's not that unique, in my opinion. However, the most important thing here is that you need to remember that data mesh is not technology. Data mesh is about people and practice. When I often meet and discuss with people that want to implement data mesh in their organization, it is driven by IT. It's driven by people like me, tech nerds. So they're looking at the technology, how to implement this. As a consultant, I'm happy because this means more work for me. I can get hired in to build a huge report about how data governance should be implemented in a data mesh. And when it comes to the purpose, I will be hired again 2 years later because it's failed. And I've done this, it's sad to say, but you've gone through everything. We've been in workshops. The users have said, yes, it's important that we own this data. And said, well, you are going to own that data. What? No, not me. So because we're dealing with people, pushing that ownership to the people cannot be an IT-driven implementation. This has to be involving the whole organization. So that is very important in a data mesh implementation. And data mesh, as I said, is not about technology, but because we're geeks, let's take a look at how that can look from an architectural point of view. So again, data mesh is microservices for BI. So this is a definition by Microsoft called harmonized mesh, trying to get every domain and data squads their own little sandboxes to play in, and then being able to distribute data across, and using central governance for where that will sit for the users, so where they can find the data. Then Microsoft also came up with, as part of their cloud scale, their cloud analytics, their CAF framework, best practices for cloud adoption framework. There is an enterprise scale lens for analytics called cloud scale analytics. And that is also data mesh-like pattern support, because you have your data management landing zone, which is your central data hub. And again, Microsoft and most cloud architectures go from a hub-spoke perspective. So this is your hub where everybody comes in. That's where you make sure that networking is okay. You monitor and support the different parts. You have your central governance in place, so there's a central data catalog, access control, and so on. And then you have connections out to the external parties. Then you have your data landing zone, and you can have as many landing zones as you want. So you can have one for each domain if you want, or you can have, and landing zones here are subscriptions in Azure. You can also have one central landing zone and let the different domains just access that as spokes on that again. And that has its core services to make sure that data is landed in and made available for the domains. Then you have common services like data integration, batch and stream, and then you have data products, again, more sandbox or data scientists or analytical tool belts where they can develop their data products. And of course, this can then scale out as much as you want in a complex organization and distribute across. Of course, if you spin up that, I have actually tried to spin that up, and I had to beg on my knees to get my credit card reopened. But yeah, but complex scenarios exist. So this is an example of a customer that is having several business domains or independent business units with their own analytical sandboxes in different clouds. And this is where companies like Snowflake or Databricks shine, because they are cloud agnostic. So in this example, we have one analytical system in AWS and one in Azure. And you can even have something in Google as well if you want. And then in this case, we also established a common platform to align and map the different, for instance, things like customer or other master data objects. Each of them were then given a Snowflake subscription where they could load their data in. And the strong thing about Snowflake in the data mesh prospect is that they have a marketplace, a very mature marketplace where you can offer data internally or even externally with other Snowflake users. And that goes across countries, it goes across regions, and across clouds. So in this case, they just built their own internal marketplace, but again, yes, you can both sell and give away for free data products in that marketplace.
So if I understand correctly then, if you go back one slide, in the marketplace for Snowflake, that would works as kind of a data catalog?
Yeah, a data catalog, but also the central place where you can get access, the interoperability of the data.
Cool.
Yeah. So, and it's very easy. You can just go into the marketplace, you can query for something as you would in a data catalog and say, okay, this is a data product. I want to have access to it. And then the owner of the data product has defined a user agreement that you have to accept. Either it is paid, or it is a trial version, or it's completely free. And if it's a stream, or if it's just a single load, and so on. So it's quite handy. So the new kid on the block, I guess it's a bit invisible, but there's Fabric. Fabric is also being, much to my despair, being sold as a data mesh. It is not a data mesh. However, there are tools within Fabric that allows you to build a solution that can support the data mesh, because you have a construct called domains where you can group one or more workspaces within that domain, and that means that you can assign capacity units and storage to the number of workspaces within the domain, which again allows for a certain kind of data mesh approach. It's also, as the name says, Fabric. It's Data Fabric, which is Gartner's attempt at the same thing. I did not mention that earlier. Gartner, by the way, for some reason, claims that data mesh is dead while Data Fabric is still alive. I don't know why. When we're talking about domains and domain-oriented approach, domains can be split in two. So you have the source domains, and as we discussed earlier, the owners of the source domains tend to be the DBAs. And the DBAs, you know what the DBA stands for? Just don't bother asking.
I've heard default blame.
That as well, yeah.
Mhm.
Yeah, but I'm a BI guy, so don't bother asking tends to fit the DBAs more, from my point of view. But the source domains, again, making sure that you put ownership to the DBAs, but you also then set demands on them. They have to be the ones who are pushing data out. And then you have the consumer domains, that's the business users. And they can either talk to each other and agree on a set of interchanging, or you can have a common data hub where that can be, one is loading in and the other is pulling out and building. So it's often this tends to be a easier approach to implementing these kind of things. And the most important thing, again, is we're not talking about technology, not talking about architecture, we're talking about organization. So making sure that you look at your organization in a decentralized way. But it's also one of the things that I tend to argue or quarrel the most with some of the most fanatical data mesh proponents. I've talked with people who are very set on data engineering not being a skill. Data is not a skill. Everyone knows data. So we don't need BI people. We don't need data engineers. Business can build their data products themselves. It's no problem. And most of these people, they are also then in organizations where there's a high level of data literacy. So do you want the domain, different business users or business domains to actually then hire one data engineer to support them? Or should you have a centralized or part of the organization being a center of excellence where they give out or dedicate the data engineers to different business domains and help the users that way? It's different approaches, but it's also something that is very important to consider in this, because you don't want to be that single data engineer in finance. You will get bored and quit. But if you had somebody to talk to, a community to belong to, and you're just borrowed out to finance, that might be survivable. I had an auditor claim very fiercely that auditors can also have fun. But yeah. So from a source side challenge is, of course, making sure that the producers understand that data is not just a byproduct of whatever their tool they're building, but it's also a product that has to be consumed. It's somebody who wants that data. And this is a core challenge when you're dealing with microservices approaches with independent development teams who don't really need to think about anything other than their own little product. Making them understand that they need to deliver data out, and it has to be in a manner that can be trusted and supported. So yes, I promise that I dedicate and support this API or this data set at least 1 or 2 versions after I really release the new one, and then I will warn you afterwards. And making sure that they do this is hard. And this, again, you can send a data engineer in there and extract that data from them, but then you will not get that ownership of the data inside the team. It will be Rune here, he's the data engineer, he built that, it's his problem. So you need to go out there, talk to them, explain, help them to create a data product, and then make them commit to that afterwards. It can be hard. And again, that is the center of excellence type of approach that if you have to go full data mesh, is the one I tend to prefer. Then you have the consumer side. And one of the core challenges is, of course, that you have business users and analysts who understand their role, not just as the consumers of data and reports, but the people who are producers and owners of that. Because analysts are made or are hired in to come up with solutions and find solutions in the data, but they don't want to support it afterwards. If somebody calls them and says, hey, this data set hasn't been refreshed, it's not my job. So making sure that they understand that part. And having them gaining that data engineering mindset, it's not just about fixing something, it has to be reproduced and be a data product that can live and be updated for over months and years. It's also something that can be sort of a challenge. So maintaining this over time, making sure that the ownership between when you have two different data products and another analyst has said, hey, these two products, if I add this Excel file into the mix and build a new product on top of that, and then there's another one saying, hey, that product and this product together with this is excellent. And then suddenly you have 4 or 5 layers of data products that are dependent on something else. And it is being maintained by Rune or by Maria here. And then Rune gets fed up with my whining and he quits. And suddenly there's nobody maintaining that data product anymore. And it fails. And then Maria, who's built her excellent products on top of that, starts wondering what happened. So you need to have that kind of mindset, that kind of functionality built in, so it's not just one single person, it's actually the organizational change to maintain this hierarchy of interdependent products. And again, one solution can be that you have independent data product builders, but you have a central team, a central excellence team that can hand over that and just maintain it for a while. Then we have to talk about contracts, because you need to make sure that the data is adhering to the central principles. But you also may need to make sure that you have a service level agreement on pushing that data in. So yes, I promise that when I push this or publish this data product, it will be maintained at an interval of every 10 minutes or every day or every month. If I have to do changes because backend data types are changed or so on, I will warn the users, or I will at least keep 2 different varieties of this or versions of this running until, say, a month has passed, so you have time to adapt to the changes on your end. And then you have the data product license agreement, or the end user license agreement. And I know that when I take this, I know it will be updated at regular interval. I know that the content and the quality is what I saw the first time. And I'm willing to to pay for it if it's needed, because of course there's a cost and the companies love internal billing. And if I build products on top of this, I take ownership of any changes going forward. These kind of things. So these are agreements that need to be in place. Unfortunately, I haven't seen any good products that can handle this yet, but I'm pretty sure something like that will come along. But it's something that you need to have in the back of your mind if you're building a data mesh. So is this for everyone? No. I claim that if you're talking a full-on data mesh, at least 80% of us will never, ever need it. It is something that everyone wants. It's been high on the hype cycle, but you will probably be able to make use of some of this. So data product, domain-oriented thinking, great. Independent data squads that can build and move faster than a central BI team can, great. And having to not argue with DBAs about access to their databases, fantastic. But the full thing, it is going to be hard, especially the organization and human handling part. Yeah? So I don't think most people will ever need it. So what do you need to think about? Well, do you have a complex source system landscape? Are you doing just microservices? Then data mesh might be a good idea. Do you have lots of domains, clearly defined domains in your business, or are there typically 3 or 4? So if you have many very well-defined domains, again, data mesh might be a good idea. If you don't, it will probably cost too much. And then how mature and data-driven is your organization. If you're going to put all the ownership of the business domain side on the users, they need to be data literate. So if you are not data-driven already, you probably aren't mature enough to be a data mesh. It will cost way too much to get the users up to speed at the same time that you're building that data mesh. Are we on time?
10 minutes.
10 minutes left, because I think we are roughly where we are. But yeah, I'll just extrapolate it a little bit. Again, data mesh is one of those hype things that a lot of people have read into and said, fantastic, we don't need those stupid assholes in BI anymore, and I apologize for the French. And again, it's a certain type of developers rather than BI people or data people who have really pushed into this. And I've talked with people who are talking about a pure mesh versus a hybrid or impure version like what I'm talking about, where you have, and one of these guys, he was talking about blockchain, because then you could have the mesh. Everything was in the chain, so all the products could be published in the chain. And I said, well, where's the data? Oh, well, there is a protocol under development that had a distributed approach to this as well. That was also part of the mesh. And, well, what can we do now then? Well, he wasn't sure, but maybe in 30 years. But the main challenge are the people who are pushing from IT as architects, pushing the data mesh approach, saying we don't need to know data, everybody knows it. And whatever the business needs, that's not really important. The most important part is that we don't need to think about it anymore. And again, it's a very expensive approach, and as a consultant, fine, you can hire me. I work for Deloitte. You're welcome. Call me. But it will be expensive, and I don't think people have really thought the things through. But in certain scenarios, in large organizations, data mesh can be a really good approach. But back to the thing again, domain-oriented thinking, data products, independent data code, enabling users to actually analyze and get access to the data, which again is slightly hard for traditional BI people who are used to just feeding people a report. So there's a balance here, and it's important to think of that while you are discussing a data mesh. Mm-hmm. And with that, I think we can say, are there any questions?
Any questions online?
There was one behind there, yeah. So small to medium businesses and data mesh. Again, I think the main important thing is how complex is your system landscape, how clearly defined are your data the business domains, and in small business they don't tend to be. I don't advise against it, but keep in mind again the complexity. I would rather say implement parts would probably fit better for you. Yeah, so you are in a business that has some very mature departments who want to own their data, and if it's okay to let them do that and then partially implement the data mesh and let the others be central, yeah, that's possible. And again, the most important part here is governance, making sure that they do take full ownership, that they follow, and that is one of my gripes about the data mesh and governance that I didn't mention earlier. Makes my heart or my brain ache, is decentralized governance. My boss is Johan and Rune, I'm pretty sure, and he said that the customer is defined as somebody who we don't want to talk to, whereas Rune's boss said that, oh, it's the most important person in the business. But since my boss is bigger, he loses. You need to have a central governance in place, or at least an overarching governance, otherwise people will start arguing. So central governance, by all means, let them, if they're mature enough, go around and build and discuss with them, do you want to maintain that, or do you want to hand that over to us afterwards? And in that case, make a process for it. But yeah, sure. Anyone else? Yeah. Yeah. So if you can have one central or some central objects that are maintained centrally and the rest distributed, yeah, that is possible, and that is one pattern in a data mesh ontology that you can look at is having a central common data models or common data objects such as customer or date dimension or something like that. Also, if you can decentralize but have one common, and yes, that is also possible. And again, that depends on how your organization wants to implement and how that ownership can be done. Is it business or can we do that in IT? It has to be agreed on, especially if you're fully implementing a data mesh, it has to be agreed across. Yeah. Did that answer the question?
Yep.
Perfect. All right. Again, I hope you can give us feedback and at the same time donate to charity. If there's anything, here are our contact details. And with that?
Yeah, and the slides will be available. I'm not sure where they will be available.
Probably if you look at the agenda, we upload them to Sessionize, which means that they typically be available for download there, but we'll see. Otherwise, we will make sure they're available on one of our GitHubs.
Yeah.
For some reason, people think I'm Santa, at least during Christmas. So my nickname is SQL Claus. If you go to GitHub, you will find my SQL Claus there. I'm also partly also covering for David Letterman. When I'm in the US, people come up to me and say, "Thank you, Mr. Letterman, I'm a huge fan." And then I laugh, and that busts me because I do not laugh like David Letterman. All right. Thank you very much.
Thank you.